plus by 2000 multiplied by 67.222 minus by 5 and the whole thing squared. Okay, so the first one is 200 times 10 power 3 by 12 plus by 2000 times by 67.222 minus 5 close bracket squared is equal to 7.759 or 7.760 times 10 to the power 6 millimeter 4. So I'm going to do IZZ2 and I'm going to focus on the diagram on my table. So you can see a trend that's going on. So this trend is, this is 2. Oh, sorry, too thick. Okay, so this is the 200. And next is the 10. And then you get the 2000. So I'm just looking at the table. And I don't need to focus on the diagram, but you need to be sure that your table is correct. Okay, so when you do your calculation this way, okay, it's very difficult to get it wrong. Okay, so 10 150 cube over 12 plus by 1500 67.222 minus by 85, okay, squared. So as I said, by using this method, you don't need to look at the diagram. You just focus on your table. So 3.287 times 10 to the power 6 millimeter 4. And lastly, we get your IZZ3. Okay, so likewise, when I was doing the previous one, okay, or IZZ2, I just pull the number down here. I've been teaching this course a lot of time. Students make mistake because they don't do something like this, okay? So I hope you all will follow this sequence. As I said, it's very difficult to make mistake, okay? But you need to be sure, you need to check that your table is correct first, okay? If your table is wrong, then you make mistake. Okay. So I'm going to do the same thing again without looking at the diagram. So you have 100 multiplied by 10 cube over 12 plus by 1000 and then multiply by 67.222 minus by 165 squared. So 100 10 power 3 by 12 times 1000 times by 67.222 and 65 close bracket squared. So it's equal to 9.569 times 10 to the power 6 millimeter 4. Okay. So all we need to do now is add all of them together. So from here, we know that IZZ will be equal to 7.760 and then we're going to have 3.287 and then 9.569. So this will be equal to 20.616 times 10 to the power 6 millimeter 4 or 20.616 times 10 to the power minus 6 meter 4. Okay. So we found our IZZ. Okay. So the next thing we're going to find our PCR. So it's pi squared. Young's modulus is 200 times 10 to the power 9. IZZ is 20.616 times 10 to the power minus 6. And then we are going to divide this by LE. So the length, so one end fixed, the other end is free. So you will have 2 multiplied by the length. The whole length is 4. Okay. And then we squared. So from here, so our PCR is equal to 635.849 times 10 to the power 3 Newton. Okay. So now what we are given is given that the P applied, right? When the P, sorry, is equal to n times 10 to the power 3. That's what we are given. But we are also given that factor of safety for yielding is equal to 3. Okay. So we therefore know that the P, or given that the axial load, this is not P, okay? So given that we are given that the axial load, okay? So the factor of safety is 3. So when we calculate our P for the formula, it is 10 times 10 to the power 3, and then we divide by 3 again. Okay. So this is what we designed for, because we have to consider the safety of factor. So 3.333 times 10 to the power 3 Newton. So this is different from centric buckling, right? Centric buckling is different from here, right? Where we have centric buckling, right, which is over here. We have a PCFOS, factor of safety, is equal to PCR over P allowable. But for centric buckling, okay, P is equal, so this is our P applied, or our axial load. And then we divide by 3. Okay. So we are in fact designing this for with a factor of safety, divide by 3, you get 3.333. Okay. So from here, we are going to put in the formula. Let me write up the formula again. Okay. So we have P over A 1 plus by EC over R squared secant, and then we have a pi over 2 squared. Now this is the P over here over PCR. Okay, so this is the P that we are designing for. Okay, you can see this P is this value, this P is also this value. Okay, so from here we are going to determine our stress max, but there are still some terms that we don't have. So we know the next thing is E. Okay, so this is where this question is critical. So I'm going to get this diagram. Okay, so we found that our y bar, right, from here is equal to, we have a value. I forgot what is it. It is equal to 67.222. Okay. Now, where point A is, okay, let me get the diagram. Okay. Where point A is, right? As you can see this here, this distance from here to here, yeah, this distance from here to here is equal to 20 millimeters. Okay. So therefore, our E, right, our E is equal to 67.222 minus by 20. Okay. So this value is equal to 47.222 times 10 to power of millimeters, or 47.222 times 10 to power 3 meters. Okay, so there is our E. And then the next thing we have to determine is our C. Okay. Now, looking at how our structure will deform, we know it will based on where I'm going to draw the green line, which is our centroid. Yeah, I'm going to draw a green line, which is our centroid. Okay, so that's our centroid. I'm going to draw it closer if I can. Okay, so as you can see, point A is on the left-hand side of the centroid, right? Like over here on the left-hand side of the centroid. So the moment will go this way. So this is moment, if I were to follow our axis, this is moment about Z. Okay, that's our moment about Z. So when this is the case, over here is under compression. Down here on the left hand, on the right hand side will be tensile. Okay. So we know that buckling will occur due to what? Compression. Right. So i.e. this surface over here, right, will be under compression, and this surface over here will be under tensile. So the buckling will focus on the compression. So when that's the case, the C, right, the C is equal to 67.222 times 10 to the power minus 3 meters, okay, due to under compressive stress. Okay, because why didn't we take this distance? If you look at the distance from here to here, right, so this distance is equal to 67.222 minus by 150 minus by 10 minus by 10 is equal to 102.222. We did not take this distance because over here is under what? Tensile. And we did state this before, that buckling analysis, okay, is only due for structure that is under what? Compression. I repeat again, right? The structure will buckle due to compression and not due to tensile. Okay. And because of the moment vector mz is in this direction, this side is on compression, this side is on tension. So you have to pick the compression side. So that's where you pick 67.222 and not 102.222. You have to get this really, really clear. Are we clear? Okay, or not? It makes no sense. Okay, so the last thing we have is we have to determine R squared